Okay, now we are in question 3. So it asks us to evaluate the limit of this. So I will write it down. Limit x. So here I wrote it down here. Question number 3. All right. So if you want to find the limit, you would just plug in 0 into the x, and that would give you it. But here, if you do that, it'll put an x in the denominator, which would make the limit undefined, which is not. So what we have to do here is make it in a way that make it in a way so like the x is not by itself, so it's not 0. So we'd start off by doing this by trying to like fix the numerator by making them have the same denominator so that you can merge them together. So you can do that by this, so 1 over x plus 8. So I'm just going to start with the numerator right here, which is what I'm doing, and that. So to get this to be the same as that, you would just add the x plus 8 on the bottom, add it on the top. And this one is missing the 8 from here, so just times 8. There's 8. So after you do that, that will just leave you with this. So 8 minus x minus 8, because we have to distribute this and then make the negative to each thing. So, and that would be over this. And now I'm going to add the denominator, which is over x, over the whole thing. Right. Okay. So for the next part, you just simplify the top. So the 8 minus 8 is 0, so that'll just leave it as negative x. And I'm going to put 8x plus 64, which I basically just solved it out, distributed it over x. So what we're dealing with now is this. So what I'm going to do is divide this part by this part. So negative x over 8 plus 64 divided by x, which is over 1. Now, to divide a fraction, you do the reciprocal, so it'll be negative x over 8x plus 64 times 1 over x, which would make it equal to negative x, and then 8x squared plus 64x. That's what we have right now. Now each term has the x, so you can cancel that x out, so it'll be negative 1 for 8x plus 64. So now, in this problem, we can finally be able to solve it by plugging in 0 into this. So here we go, negative 1 over 8 times 0 plus 64, which would equal negative 1 over 64. So the limit of x as go to 0 for this problem would be this answer right here. Now, okay. Now for the next problem, it said evaluate the limit as s goes to 0 for this problem. So that's exactly what we're going to do right here. So limit, well, it said s, so change to s. 4s minus s squared plus s. Okay. So this one is kind of similar to the last one. So you basically just want to make common denominators for this fraction. So we just be adding this to that and that to this. So let's see. So 4 over s, and then you add that to here. So s squared plus s. You have to add that to the top also. S squared plus s. And then minus 4. And we have to use the s from here to equal it out. So 4s and then s squared plus s times s from this one side. So now they have a common denominator. So basically just solve the terms on the top, which would make it to 4s squared plus 4s minus 4s over, distributed at the bottom, s to the third plus s squared. Now, okay. Now if we just simplify, so you can just do 4s minus 4s, so it'll just be 4s squared over s to the third plus s squared. And since all terms have s squared in common, that will be the same thing as 4 over s plus 1. So now we can finally plug in the 0. So that would just be 4 over 0 plus 1 equals 4 over 1, which equals 4. So the limit as s approaches 0 for this function right here would be 4. Okay. Now for the last part, I said evaluate the limit. Now this one's not x goes to 0, it's x goes to infinity for this function. So let me write that down. Now this problem says you do not need to show work for this part because there is a simple way to solve this, which would be by looking at the leading coefficient for this problem, which for this one is this one, and so they both have 3, right? So since you can probably just subtract that, you would simplify it by this. So I'm just writing this top term first, and then x to the third minus 2x to the third will be negative x to the third plus 7. So now that basically gives us negative 3, because it's the leading coefficient, over negative 1, which equals 3. So that's basically like the horizontal asymptote, which means the line won't go above that. So the limit or above or below. So the limit as x approaches infinity would be 3.